Alright, this is the last video for section 1.1. It's part 5. Alright, and we've talked about discrete and continuous as far as the definitions. Now we're going to look at some examples. So let's see what we've got. So we're definitely going to need to make sure we can figure out, discrete versus continuous. Can I tell the difference? And I'm going to need to be able to say if something is discrete or continuous. We're literally going to have later a whole chapter just on discrete random variables and then a chapter on continuous random variables. And how we work with those things will be different based on them being discrete or continuous. So these are definitions that you definitely fall under that independent label in our ESIL lens. So here's the question, though, that I want to ask myself to figure out if something is discrete or continuous. And it's, can I have a half of a whatever? And so if we go back to those, we said we could find the average number of cans versus the average amount of soda. If I'm talking about the number of cans, can I have half a can of Coke? Well, that depends on what you mean. If I say yes to that, it's because if I have a 12-ounce can and I've drunk, 6 ounces of it, then I have maybe half a can of Coke left. But do I actually mean I have half of a can? No, I still have a full can unless there's maybe a goat at this picnic and they've started chewing on those cans and eating them. But no, I have a can of Coke was opened and taken at that picnic. How many ounces were consumed? Well, for that one, it would just be 6 instead of 12 if it was left unfinished. So can I have a half? If I can, then it's continuous. So the variable or data is continuous. If I cannot have a half, if I'm counting, remember counts and measures. If I'm counting things, I don't count, 1, 2, 2 3/4, 4, 4 1/2, 5. Not if I'm counting like actual things. You either have a whole thing or you don't have a thing. So if that answer is no, then the variable or data is discrete. And so let's take a look at our diamond table again. All right, so in this case, when we're looking for any data we might have as discrete, of course, can I have a half is another question that we could ask is, can I have a decimal? And if there's decimals or possibilities, then they're definitely continuous. But that doesn't mean that all whole numbers are discrete data. So whole numbers do not automatically mean we have discrete data. So be very, very careful of that. So here we've got two things, table and price, that are whole numbers. The rest are decimals. So I'm just going to go ahead and say decimals mean that it's continuous, because obviously I can have a half or a decimal, so that's automatically there. But I want to show you something about the table, especially this variable called table. Let me pull up a picture real quick. All right, so this is, by the way, I learned a lot more about diamonds than I ever knew in preparation for this chapter. But the table is actually a percentage, and it's the table width, which is this yellow part on the diamond, it's the flat part on top, divided by the total width, so whatever the diameter is. And it is a percentage. They've rounded these to the nearest whole number, but that does not necessarily mean that table is a discrete variable. So if it's a percentage, that percentage can when you divide two numbers, you're not always going to get a whole number, and you're not even always going to get a nice decimal, right? Sometimes we get these decimals that repeat or, just go on forever and ever. So we always want to check that. That table is not, so we're not going to, we know these aren't. Let me go ahead and, so we know that's not, carrot's not, X, Y, and Z. Those were all obvious, but now we can also say that table is not discrete. And so we're down to one more. What about price? And this is actually a variable. Money in general is a variable that you could argue discrete or continuous depending on what you're trying to identify as, the characteristic. When I say price, am I measuring the value of the diamond with this, how much it's worth, measuring its value, its worth, its price? Or am I counting, in this case dollars, the number of dollar bills that someone's going to have to put down to pay for it? Even if money has to the nearest penny, there's still, we're then counting pennies. And that would be a lot of pennies if we're talking about $16,000 or $1,600. But still, I could have a number of pennies if that dollar amount had a decimal and, two more numbers after it. So most of the time and when I say we, I just mean, statisticians, mathematicians, statistics teachers, go with more of a, when you put a price on something, you're putting a value to it. What's the value of this item? As opposed to just thinking about how many coins, pennies, dollar bills, whatever, did I need to lay down in order to pay for it. So even in this case, there is an argument for price being discrete, but I'm going to go ahead and say no. So we don't have any discrete variables in this table. All right, and then of course, which of these are continuous? Of course, we said that continuous can be any number. We're measuring something. Of course, we said carat was weight, so we're definitely measuring the weight of something. It is the official measure of weight for a diamond. Depth, because I want to be careful because I want to identify these two things, because I actually used the word depth before when I had the picture on a previous slide. Table we talked about, that's a percentage. So I'm going to depth. I'm just going to leave for a second. Table is a percentage. Price is the value, measuring the value. X is the diameter. And that measurement, by the way, is in millimeters. Y is the perpendicular diameter, also in millimeters. And then Z is the height in millimeters, which could also be called the depth of the diamond. But when they say depth up here in this first column or second column, let me show you just a quick bit, just in case you're wondering. 61.4 versus 3.8. How are those the same measurement? Well, here you go. When they talk about depth in this table, it's another percentage. It is the total depth, which would actually be the 3.18 divided by the total width. And if we actually calculate that and do a little bit of some weird stuff, because I actually had to end up adding the X and Y and finding the average of those two. But when I divide 3.18 by those two added together and divided by 2, I actually do get 61.4%. So you get really close if you just take, divide these two numbers. But not exactly. So I think they must have done some other finagling or something. But anyway, that's still just a percentage. But that is, and both of these, table and depth, they're just dividing two numbers that are already measurements. So a percentage that would also stay continuous.